All right, well, it's dark here in the eastern US, 10 till 7. So it's already been a long day, and I've absorbed quite a bit about power supplies and batteries all day. So I'm going to hopefully share a little bit more of a different perspective with the Rack and Power team and everybody else who's listening in. And really, as I went kind of through this presentation, putting it together, it really falls into a number of different categories. So, the HPC track is also an area where it's kind of an interesting set of information to understand and see kind of where we've been and where we're heading. So I'm going to talk a little bit about some of the trends that we're seeing and also some of the different system solutions that are out there to really get into the battery backup space. Sometimes we kind of consider ourselves as like that insurance policy that, nobody really wants to pay for, but they know that they need. And part of our job is to identify, how do we really come up with the optimal solution for the different systems that are out there. And one of the important things to point out for anybody that's fairly new to working with batteries is that they're heavily regulated, probably even more so than power supplies these days. And they're very expensive to develop. And unfortunately, every time you make a shift, whether it be voltage or power level or any type of major item on the battery pack, you have to completely recertify. And a lot of the newer agency certifications are extremely expensive and time consuming. So what we're always trying to do is figure out how can we come up with a handful of battery solutions that can cover a very wide variety of applications. And what I will tell you is I'm not seeing a clear picture for that just as of yet. So I'm going to talk about some of the different varietals that you'll see. So one of the keys is that we're really looking at these disaggregated edge and hyperconverged infrastructure scenarios that are influencing the new architectures. So, I think as we've seen today, if you're dealing with a hyperscale data center, the UPS system that's out there has been really the industry standard. And as we're seeing in ORV2, we have more of a disaggregated system, and then ORV3 even more so. So a lot of positive pieces to it. But, if you think about some of these edge systems, if we go to the telco track, for example, we're talking about 2U high and 3U high solutions. They're not going to do a whole shelf of BBU. They only need a little bit. So that's kind of the thing we're going to look at. The other thing that we have to think about is the latency concern. So that comes up pretty frequently. And I think most of the general BBUs support the latency requirements out there. However, when we start getting into these very high-end processors and GPUs that, we really don't have milliseconds to work with. I mean, it really just has to be instantaneous. Another important trend is that the more the systems are shifting to flash, non-volatile RAM, and solid-state disk drives, it reduces the BBU needs because we don't really have much holdup time needed for those type of memory applications. On the other hand, this increase with GPU and massive parallel processing increases the BBU needs. So, they're kind of diametrically opposed requirements in a system. So the other piece of it is that when we look at some of these disaggregate deployments, there may be unreliable AC power. So we really have to think about a 5G build out type of scenario that we're going into third world nations, we're going into more remote areas. We have all sorts of emergency needs from hurricanes or bad weather or flooding or whatever it may be, that we have to basically look at a lot of these systems out there to say AC power is not necessarily always available. So that also changes what type of battery backup solution that you need for your architecture. And the other thing that we're seeing pretty much generally is new battery backup solutions need to be much more scalable and powerful and are more likely to be in the individual chassis. So, if we think about UPS typically in an on-premises application, easy to get to, easy to replace the batteries, not that big of a deal. You have cabinets sitting next to each other. But when we get into a lot of these edge scenarios, we're finding that the weight of seal lead acid just is not palatable. And the latency requirements and the fact that we have to do a lot of power conversion when we're working with a UPS as opposed to a direct attach BBU, and whether it's a 12 volt or 48 volt, really becomes a really positive way of doing it. But again, as I mentioned, there's no one size fits all solution. So that's why you'll see most lithium ion batteries in general in the industry, whether it's consumer, data, telecom, they're mostly custom. And it's because of all of these reasons. So I'm going to try to go pretty quick through because some of these topics have already been covered. We'll talk about some of the overall design parameters, some of the different configurations. I'll show you some examples, talk a little bit about scalability. You can't talk about batteries without somebody at least wanting to know a little bit about cell chemistry and options, and then a little bit about safety considerations and agency testing. So even if we take a look at just the systems within Open Compute and in any of the telco type of systems, we have 19, 21, 23 inches wide. There's RU and OU form factors. We have 2 different voltage levels. Each one of these chassis are going to have a different type of load. Network, server, storage. Again, as I mentioned, you can have archive storage with a hard disk drive, or you could have local dynamic storage with solid state, or you may have a combination of both. And we've also had lots of conversations today about regulated versus unregulated output on the BBU. So, those are things that all have to be figured out on the front end. And then we need to know the power output and the nominal and peaks. So, I remember working with one UPS manufacturer, they thought a peak was 30 seconds. We said, no, that is a continuous load. A peak is in maybe a second or less. And we need to know the temperature range of the system because a battery backup solution is heavily dependent on the temperature that you're working within. Also, we have to understand what's a runtime per power outage, because clearly we need to put in enough cells and power the system enough so that you're going to cover what your typical outage is going to be and how frequent are outages. So if you think of a lot of your typical home power outages from a storm, power might go out, then it comes back on, then it might go back down. So what some customers do is they'll actually build enough power into the system to support 2 back-to-back outages. All right, because ultimately what you want to be able to do is have enough runtime so that the system can figure out how to shut down gracefully so that when the power comes back on permanently, the system will boot back up properly. That's a really important element that the system architect has to design around. The other thing we were talking about today is system life expectation, calendar life. So for example, the OpenRack version 3, we were talking about having 5 minutes of runtime at the end of 4 years. So what you have to do is understand how that battery cell is going to degrade over time at that temperature and how many usage cycles is it going to go through. So we have to do a lot of calculations to then say, okay, well, here's how many cells we're going to need to have in place to support that 5 minutes at the end of 4 years, which means you might start with 6, 7, or 8 minutes at the installation to run with. And the other piece that you have to understand is your physical environment. So again, if we're in a hyperscale data center, maintenance, accessibility isn't an issue. But if now we're putting a micro data center in an office building in the middle of Manhattan, accessibility isn't necessarily that easy. And then if we're talking about some of the smaller systems that might be in cell towers or even in more remote applications, you're going to say, well, I can't really get to that solution very easily, or if I do, it's going to be very costly. So those all have to be put into the consideration in the design. So because I'm limited in time, I'm only going to talk about what I consider as probably the 2 most typical system configurations based on a high efficiency and low latency scenario. So those 2 are going to be either blade based, which means that you're putting the battery module either directly on the server or data storage card or blade, or in the subsystem, or like we've already gone through quite a bit today, the modular power shelf, which the ORV3 BBU is pretty representative of. What I'm really going to kind of skip today are the three other options. As we've mentioned, a standalone UPS chassis, industry standard, people know what to do with them. You know, there you go. You have your whole chassis filled with a bunch of sealed lead acid batteries, and you're doing a lot of AC to DC conversion and a lot of power transfer, not particularly efficient. And then you have others where you have an in-chassis UPS that is basically built up in a stackable configuration in increments of, let's say, 1 kilowatt, 1.5 kilowatt at a time. And then others where you're like the Microsoft Olympus, where you have the BBU built into the power supply unit. So just to kind of put a quick matrix together here for the different system configurations, again, with the focus on the high efficiency and low latency, I'm pointing to the blade server and the modular BBU power shelf. And if you think about the efficiency on the blade base, it's essentially because, and I'll go into that in a little bit more detail, you are building specifically for a load. So you only have just as much battery energy as needed for however long that you need to run. So it's clearly low latency. And when I talk about the design cost, however, it means that it doesn't matter if I'm building a 3 kilowatt or a 100 watt battery. Most of my costs for the agency certifications and being able to ship that product globally are pretty much the same. So, you know, we're amortizing an NRE, we're amortizing agency certification costs over, you know, let's just say it's $100 or less battery pack as opposed to a $300 or $400 battery pack. So your costs are relatively high. You know, the modular BBU power shelf, it's an expensive proposition because we are talking about a higher amount of energy, and that is going to call out for some of the newer different agency certifications that I'll get to a little bit later. So you guys will all get this presentation, so you can take a look through and ask me any questions. But essentially, this is kind of a breakdown of kind of how I look at some of the different configurations. So these blade or modular BBU solutions we've been doing for, you know, well in excess of 10 years. So if you think about a lot of the traditional storage device and the typical big iron type of guys, you know, the ones that are the I's, the E's, the D's, the N's, you know, those type of guys, they've traditionally used this type of battery backup module. So, you know, you're really dealing with, you know, 10s to 100 watt maybe to just support the backup on that blade. So it's good because it's designed specifically just to support that load. But your challenge now is that you now have a battery on your server card. So depending on how you designed that server card, you're kind of locked in for a while, unless you make it really pretty modular. So what we're finding is that for the companies that are still using this type of BBU application, what they try to do is come up with a modular solution that can support a variety of platforms at the same time. So the latest one that we've worked with, they're using it, I think, 4 or 5 different platforms. So it took a little bit more time to kind of develop the pack so that it was going to work for a wide variety of units in their application. And again, this is something that's been around for a long time. And this does become important because as you think about a system architect, you know, building out a full, you know, 40 or 42U high chassis, what they're going to have to understand is, well, do my servers or my storage blades already have BBU built into them? Because then I don't maybe necessarily need to have a full system battery instead. So that's part of what they have to take a look at and understand what's really the best way of going about it. And then when we've taken a look at doing a full modular BBU power shelf, you know, as we can see, we're breaking it down to 3 kilowatt modules for ORV3. And, you know, the questions were asked earlier, well, you know, how do I kind of scale with that? Well, either you don't populate the whole shelf, or if you need a little bit more, you do a second shelf and then you populate to whatever level you need. So that's pretty neat. Now, we've had other customers that have come to us to say, I'm not necessarily so keen on lithium ion, I want to take a look at a different chemistry. So what's kind of nice about this particular architecture is it's not just locked in for a particular cell type. So as you see, we can use lithium iron phosphate. We could build this with nickel metal hydride. Some of the new nickel zinc chemistries are coming out. So, we can configure them differently based on what the customer needs and have a mechanical chassis that maybe supports both. Another thing on the battery side that becomes really important, and I don't really get into this in too much detail, but we have power, energy, or hybrid options. And what that means is essentially that I have to choose different cells depending on what the customer is really looking to do. So when we talk about a traditional BBU and we talk about 5 minutes, that's a power application. That's essentially saying, okay, I need to be able to take over the complete power of the system and operate it for 5 minutes. And that's all fine and good, but we also assume that the system is going to shut down at the end of that 5 minutes. If it's an energy application, now we're talking about, well, no, actually, I want you to be able to absorb that initial inrush current, but now I need you to run continuously for a while. And it may be because the generator isn't turning on, or maybe it's just in an area where there's no generator at all. So, we're seeing some of these 5G applications and they're saying, oh no, I need you to run for 30 minutes, 40 minutes, an hour. I need to be able to scale this so that you can essentially just take over and you are the generator now. And then there's some in between. So when we talk about scalability and system integration, as I've already referred to, we have a lot of different loads that need different runtimes. So, if we're running a lot of NIC cards, don't need much. GPU could require 10 to 15 minutes. But as I mentioned, if we're dealing with a lot of memory and it's SSD and flash and VRAM, we don't really need all that much, because the key here is data integrity. That is absolutely the most critical piece of it. It's just saying, all right, I have a power interruption. I cannot corrupt my data. So the battery has to be there. And that's why I talk about it like an insurance policy. So we also have now this critical versus non-critical application. So if we think about IoT for automotive, the speed and the intensity of that is so beyond my grasp. But to think about, oh, we have a power interruption out there because a microburst storm came through, and now those cars don't have any sensor data, and now they're all lost. To me, that scares me. So you have to think about that and say, well, that's mission critical. You have to have battery backup for a while for that. But if you're dealing with email or social networking, it's not as critical, and that's also information that's going to go back to the hyperscale data center and not stay out there at the edge for processing. So we're seeing that as something that really drives that scalability for the system. And then we have also, and this is another area, lithium ion types have logistical and safety challenges. So what you'll see is you might be an integrator and build out a whole rack and say, oh, but I'm going to go ahead and ship the batteries directly to the site, and I may not actually have certifications to transport that product. So I might actually arrange with the OEM or a distributor to transport the batteries separately from the rest of the chassis. So something to consider. And then also in the next slide, we'll talk about NFPA type of scenarios. I know I'm running out of time here. Again, different cell chemistry options. Probably the most important thing that I could say right now when we think about some of the data center scenarios is that the NFPA is setting up some of these new standards and guidelines. And essentially we have some thresholds based on the chemistries. And we're working with my CTO and the PRBA on getting a more decisive commentary on it. But essentially we have thresholds of 20 kilowatt hours banked together and 70 kilowatt hours. And this is going to be important for more so how the battery packs are manufactured, and then also how many chassis can you actually put together before you have to go to a gap between them. So again, cell chemistry options, you all can read through it. Obviously, we do a lot of lithium ion, but in this type of space, lithium iron phosphate is getting a lot more play these days, and then some of the newer nickel zinc are coming online as well. Yeah, we talked about some of the certs. Probably the most important ones to understand is UL 1973 and IEC 62619. And essentially, what they focus on is the mitigation. So if you have an individual failure of a cell, it cannot affect the rest of the pack. And what that means is that we have to either put more gaps between the cells, or we have to add materials in between the cells and do a very careful mechanical design to make sure that, again, that one cell does not create a chain effect. And am I out of time, Caleb?
We have a couple minutes. 2 minutes?
2 minutes, okay. Well, just for anybody that isn't following the telco track, this is one of the other solutions that we've had presented out there to the Telco Edge group for about a year now, year and a half. And it's a modular BBU solution for their 3U high chassis. So this is a 12 volt, 1.6 kilowatt solution. And this is something that really kind of goes to that premise of a modular solution that's scalable for those smaller edge systems. So as you can see, it's not a 3 kilowatt times 6, a lot smaller, but uses a lot of the similar topologies and architecture. And then as we've talked about the Modular Hyperscale ORV3, don't need to go into that, that's been covered well. And then just even, another potential company that we've had some conversations with that are a little bit more nervous about lithium ion. And they've asked us to take a look, well, what would something like this look like using a nickel zinc or nickel metal hydride solution? So again, the architecture is really good. The modularity and scalability is good. This offers some advantage, just doesn't have the same energy density as that of a lithium ion pack. So how can you get involved? Well, you can join the Rack and Power or HPC or telco community and share information with us about some of the different industry applications that you're seeing as we really work our way out to the edge. There's a lot of creativity that's going on out there, and as you can see by what I've shared tonight, there's just a lot of different ways of getting the battery backup in your system. And then, whatever else that you can add for concepts and system build out options. There we go. Thanks. Any questions?
Thank you. Hamid, it seems like throughout the day you've been getting questions faster than I have, and I'm not seeing any. Are you seeing any on your side?
I see one question from Brian. It says, seems a bit unrealistic for telco providers to expect BBU to supplement building level critical higher than 20 to 30 minute hold up. If a bridge to extend the generator switch over time and or modularize some of the storage in order to reduce the building level, then that makes a lot more pragmatic sense. That's a comment from Brian. Howie, do you want to add any comment to that?
No, but what we're seeing in some of these telecom applications and some of the commentary where you're supporting potentially a telco solution and a data solution, there's a lot of gray area, and we're seeing questions come up to say, can we support both? So, we have to think it's probably more in the edge scenario. Again, if we're dealing with a traditional data center architecture and we make the assumption that there's going to be a generator, then yeah, you don't need that much of the holdup time. But again, we can't make those assumptions as we get further out into the field. And that's part of what I'm really kind of pointing to. It's not necessarily referencing, just what we're looking at within OCP today. It's more about, what are we looking at, 3, 4, 5 years out? And, what are those solutions going to look like?
I see. What are the, like, in your mind, what are the industry, like, backup time requirement for the, like, for in-rack BBUs?
Well, the 5 minutes is kind of an industry standard. And a lot of that is based on solid state, on a hard disk drive. So, if your system is all SSD, then you could probably shrink that to 2 or 3 minutes.
Mm-hmm.
And, that's kind of what we're looking at.
Yeah, hard disk still dominate the industry because of its better pricing and more compact, as far as I know.
Yeah, I think it really just depends on the system because, I asked a lot of questions. I think the HPC guys are kind of like, well, we just assume that we're going to have a generator and we only need, maybe 30 seconds. But, I have to look at things to say, well, what if the generator doesn't kick in and it's a much smaller data center, or they accidentally didn't refill the diesel, don't know. So how long does a GPU process in, a critical application? I think Hamid, you've even commented, sometimes you're looking at 5, 10, maybe 15 minutes.
Yeah, I think that could be industry-wide. Something that we were thinking on OpenRack V3 BBU was to have a modular system. So in case someone wants 10 minutes, they can put in 2 battery shells.
That's exactly it.
Like 15 minutes, they can put more. But I thought they start as a 5 minute as a base. We found it's a good starting.
Absolutely correct. 5 minutes. And by the way, that is a consistent hold up time from almost every UPS company that we work with. They all use 5 minutes at the end of 4 or 5 years, which is also what they are putting in their warranties. So to them, it's like, I need to know 5 years down the road that you're going to give me that 5 minutes. So,
yeah. All right. Thank you.